In this video, we will continue the volleyball projectile motion problem. We will be doing part B that asks how high does the volleyball go and when does it reach its maximum height. Okay, so recall that there are two components for projectile motion. There's the x component, which is initial velocity cosine angle t, and then there's the y component, which is initial velocity sine angle t minus 1/2 gt squared. Okay, so to find the maximum height, you're going to want to take the derivative of this, and then you want to set it to 0, and then you want to solve for t. This will tell us when it reaches its maximum height. So let's go ahead and get started. Derivative of this is v initial sine a. Derivative of this, you take the 2 down, you get minus gt. Set that to 0. However, we want to solve for t. That means that we have to add gt on both sides, which gives us v initial sine a minus, no, there's no minus because gt is in the other side, so you get gt. You want to isolate t, so divide both sides by g. You get v initial sine a over g equals t. Okay? Now, substitute the known values into the equation. So, what do we know? Let me erase this so that our workspace is clear. What do we know? We know that the vector, the initial velocity, is 46 feet. And we know that the angle is 28. We also know that the acceleration due to gravity is 32. So we know a lot. Now we want to plug that into a calculator. 46 sine 28 over 32, you get 0.6748, which is around 0.675. So this is the time it takes to reach its maximum height. Now, you want to substitute this t value into the vertical component of the vector. So, recall last video that we solved for the horizontal component and then the vertical component. And this is the vertical component, 4 plus 46 sine 28 t minus 16 t squared j. Okay, substitute this into here. We then have 4 plus 46 sine 28 0.675 minus 16 times 0.675 squared j. Substitute that into a calculator. You get 4 plus 46 sine 28 times 0.675 minus 16 times 0.675 squared. You get 11.287. 11.287 feet. So this will be how high the volleyball goes. This is how long it takes in seconds to reach its maximum height.